In this video, you're going to learn how to read documents from your MongoDB database. This is going to bring us from C for create to R for read. We're going to be able to read individual documents by ID or by any other field, and we're also going to be able to fetch multiple documents, limiting them to a specific subset, like users whose age is 27 or tasks that have yet to be completed. Before we get started, let's go ahead and remove these three lines related to the object ID. Remember, all of the stuff covered previously is always available in the PDF guide, and you could always choose to leave that code around if you wanted to. And down below, I'm going to remove all of the code we have in that callback for our 4 calls to insert one and insert many. That's going to leave us with an empty connect function we can use to explore how we can fetch data out of the database. Once again, documentation for insert and insert many can also be found in the PDF guide for the class. So when it comes to fetching data out of the database, there are 2 main methods we're going to use. We can view both over in the documentation for collection. This is the same area where we found the insertion methods. We are looking for find and find one. Find is going to allow us to fetch multiple documents out of the database, such as people who are 27, and find one is going to allow us to fetch an individual document. Now, there are other methods that start with find, but those are all related to other things like find and modify for changing a document, or find and remove for removing a document, and we'll talk about updating and deleting data a bit later. For now, the focus is on find and find one. So let's go ahead and start the process of fetching some data out of the database, and we'll start with find one to find an individual document. Let's pull up our users collection and pick a user we want to fetch. I'm going to fetch this one right here with the name equal to Jen. So let's go ahead and do just that by first specifying the collection we're trying to use find one on. So db.collection. Right here, we pass in the string users like we had before when we were using insert one and insert many. And then right here, we're going to use find one. Now, find one accepts 2 required arguments. The first is an object and the second is a function. So the object is used to specify our search criteria. If we want to search for a user by their name, we specify a name field on this query object and we provide the value we're looking for. In this case, capital J, Jen, is the name we're searching for. Now, the callback gets called when the operation is complete, and we either get back an error or we get back the actual document. So I could call this user, which would be an appropriate name, though you could call it whatever you liked since it's just a function argument. Down below, we can now do something with the response. First up, if there was an error, we can go ahead and handle it by returning using console.log some sort of message, unable to fetch. And then down below, we can actually dump the user to the console to view that document. So console.log printing user to the screen. So with this in place, I would expect that we're able to find our one document since there is a user with the name of Jen. Let's go ahead and save the program and run the script from the terminal. That's node mongodb.js. When I run it, what do I get? Right here, I can see my one document printing. I have Jen's ID, I have the name for Jen, and I have the age 28. All matches up with the data stored in the database. Now, in this case, we're just searching by one field name. We could also choose to search by more fields by specifying those on the list. Now, what happens if we do search for something else like age, but we provide an age that would return no results, like 1, for example? There is no Jen inside of our database with the age of 1. Now, what's going to happen is not an error. This is still a completely valid operation. If we save the program, we can rerun things to see what we get. Down below, what do we get? We get null. So searching for a document and not finding one is not an error. Everything did go well. We gave you back what you asked for. There was just nothing to give back. It was able to correctly communicate with the database, though, and go through the process of searching for what you were looking for. Now, find one always returns just a single document. If your query matches multiple documents, it's just going to grab the first one. So for example, there are 2 users with the name of Andrew, it's always going to return this first document if we just searched for name Andrew, and we have 3 users who have the age of 27. We're always going to get the first one back. Now, if we wanted to search for a specific document, we could always do that by its unique identifier. So let's go ahead and do that before moving on to find to search for multiple documents. Right here, we're going to go ahead and grab an ID for one of our documents. You can pick any one you like. I'm going to grab the ID for Vikram. Now to grab the ID text, we can just right-click, click Edit Document, and we can grab right here what's inside of quotes. So I'm going to copy that to the clipboard, click Cancel, and I'm going to bring that over to mongodb.js. Right here, we can now swap out what we have inside of the query object. Instead of searching by name and age, I'm just going to search by ID. Now, it's not enough to provide a string ID, so I can't just open and close a set of quotes and paste that ID in. Remember, in the last video, we learned that what's actually stored is an object ID. It's not a string, it is binary data, so this search is going to return no results. And it's a common error, so I do want to save it, run it, just to prove the point. Right here, file is saved. I will execute the program once again, and we do not get any results back. If we want to search by ID, we have to provide an object ID, so we have to use that function we talked about earlier. Right here, let's go ahead and wrap this string in that function call. I'm going to cut the string out, including the opening and closing quotes. I'll use new object ID. Then I'm going to pass to it the string that I just cut out. Now we are providing a valid object ID in the query object, and if we rerun the program, we are indeed going to get the result expected. So right here, I can see that we do have the document showing up for Vikram. Now you might be saying, hey, that's a lot of extra work. Why can't that just be done for us? A little bit later in the course, we will learn how we can avoid calling new object ID, but for now, that's the standard way to get things done when using the MongoDB native driver. Now, finding one document is a good start. We can also use find to find multiple documents. So we could search for users by name or age, or we could search for tasks by any criteria, like whether or not it's been completed. Let's go ahead and set up a call to find. That's db.collection. We're going to search in users once again, and we'll try to find users who have the age of 27, and we know we have 3 users that fit that criteria. And we're going to go ahead and call find to pass our query object in, just like we did for find one. Now, it doesn't make sense to search by ID when using find, since you would only ever get a single record back, since the ID is unique. So typically, when using find, we're searching by a different field on the document. In this case, I'm going to find users whose age has a value of 27. Once again, that would return 3 documents. Now, find is a bit different than find one, or insert many, and that's because find doesn't take in a callback as that second argument. With find, what we get back as the return value is actually a cursor, and the cursor is not the data you've asked for, it is a pointer to that data in the database. And the reason we're getting a cursor back is MongoDB isn't going to assume that every time you use find, you always want to get back an array of all of those documents. There are a lot of other things you might want to do, like get just the first 5 documents, or do something even different, like just get the number of matching documents. You don't even want the document data themselves. So when we get a cursor back, it opens up a lot more possibilities. Now we can explore all of this by heading over to the documentation. So if we go over to Google Chrome and we scroll down to our F methods for collection, we have find one right here. We pass in the query, which we did. We have our optional options, which we did not specify. And then down below, we add the callback, which we did specify. If we go over to find though, we can see that we still have the query and those optional options, but there is no callback as a third argument. Now we can see that we also get a return value right here of cursor. And when we click that, it's going to bring us over to something else in the docs. If we scroll down, we have cursor sitting right here. So what we get back from find is indeed a cursor. It is a pointer to data. There are all sorts of methods we can use with it. We can use things to limit the data like limit. I can count the data up with count. I can do other forms of aggregation, or I can use one of the more popular methods, toArray. ToArray is going to allow us to get back an array of documents, which in this case is exactly what we want. So over here, what does that mean for us? It means that find returns a cursor, and the cursor has a toArray method. So right here, I'm going to call toArray. Now, toArray, that is what takes the callback function, where we either get the error or we get our matching documents. In this case, we could call them users. Now let's go ahead and dump those to the console to see what we get. Since the error handling is going to be the same either way, I'm just going to temporarily ignore that. I'll use console.log to just dump users to the console. We can save MongoDB and test things out. Now I will comment out my call to find one just to clean up the output we see in the terminal down below, and I'll restart the script. I'll shut it down, start it up once again, and right here, what am I getting? I'm getting an array of 3 documents back, where each document has an age of 27. So using this simple call, I was able to fetch multiple pieces of data from the database, limiting them by some criteria. Now, to further explain why cursors are being used, we can take this call, copy it, and duplicate it down below. We're going to switch from using the toArray cursor method over to using count. Now, count still takes in a callback, and we get an error potentially, or the count. So right here, I can just call that count. Then I'll just print count to the console. So it's very similar to what we had above with a few minor changes. Now, if we rerun the program, we can see the output we're going to get. So right here, I get my array for that first call to find, and for the second, I get the number 3. So this is the advantage of the cursor. Sometimes I want to get the data, I want to get all of the individual fields back, and in that case, toArray gets the job done. But if I do want to do something simple like count, there's no need to fetch all of those records, store them in memory in Node.js, only to get a single number back. MongoDB can handle that for us. Instead of needing to transfer all of the documents across the network, it can just transfer that single integer, in this case, the number 3. So the cursor is a nice tool for us to be able to use, and hopefully this example illustrates why we might not always want to get all of the data back, while we might want to sometimes do something a little bit different. Now it is challenge time, where you're going to use our search methods, find one and find, to find documents in the tasks collection. And right here, I have some challenge comments. Right here, your challenge is to use find and find one with the tasks collection. So step 1, you're going to use find one to fetch the last task in that collection by its ID, and you'll print that document to the console. Then you're going to use a call to find to fetch all tasks that are not completed, and you're going to print those to the console as well. Finally, you're going to test your work. So when you run the script, you should see one document print the last task. Then the next thing that prints should be an array of documents, all of the tasks that have not been completed. Take some time to knock that out using the code discussed up above, test your work, and when you're done, come back and click play. How'd you do? Let's go ahead and kick things off by pulling up the tasks collection in Robo3T so we can see the data we're working with. I have that sitting right here. Now the first thing was to grab the document, the last one by ID. So I'm going to edit that document just so I can copy it to the clipboard easily. I'll close the editor and I'll bring that over to mongodb.js. Right here, db.collection, since we are trying to access the tasks collection. And right here, I'm going to use find one to find a document by its ID. So in the query object, we're searching by ID, and I'm searching by an object ID, so I use new object ID, passing in, inside of quotes, the object ID value. Now from there, we provide that second argument, which is our callback function. We get a potential error, and we potentially get the document, which I'll call a task. Right here, we can go ahead and provide the arrow function body. And in here, all I'm going to do is dump task to the console. So console.log printing task. Now we can go ahead and test our work one step at a time. So right here, I'll go ahead and rerun things. I'll shut the program down, start it up once again, and I am indeed seeing that last task with a description of pot plants and a completed value of false, which matches up with what I have over here. Next up, step 2 was to find all of the documents that have not been completed. So right here, for that, we'll use db.collection once again. We're looking in tasks, and we're using find to find documents where completed is equal to false. Now from here, we can't just provide a callback function since remember, find returns a cursor. Now we could use other cursor methods to do other things. In this case though, we do indeed want to print all of those documents, so I'll use toArray. When we use toArray, it actually goes off to the server and fetches all of those documents. Right here, we either have an error or we have our list of tasks. Perfect. Let's go ahead and print them. Console.log printing tasks. Now we're going to go ahead and run our program for the final time. Down below, I'll shut down the script. I'll start it up again. We have as the first piece of output our last item, which was fetched by ID. Then we have our array with all of the documents, all of the tasks that have not been completed. I have renew inspection and I have pot plants, both which indeed have a completed value of false. I'm not seeing clean the house show up anywhere since that has already been completed. Now this example query is the kind of query you would use if you're trying to show someone all of the things they still need to do. Now that we know how to find our documents, we have knocked out both C for create and R for read. Down below, I'm also going to remove the challenge comments since we're all done with that one. Now we do still have to cover U for update and D for delete, but before we do, we're going to take a quick break to talk about a very important asynchronous tool at our disposal. This is the promise, and we're going to start talking about it in the next video, so let's go ahead and jump right in.